is we are going to review sequences today. A lot of this stuff you guys actually did in 8th grade. I know you don't remember, but it is pretty basic. So here's the deal. We're going to have 4 parts. Part 1, we're going to find the first 4 terms of the sequence. And then part 2 is going to be when the sequence is given and we have to write the rule. Then we're going to take a look at recursive properties. Then we're going to talk about factorial. And factorial is truly just an exercise in simplifying a fraction. All right, so here we go. Part 1. All right, so here's how this works. The letter N is the order of the term. So this says A sub n. A sub 1 is the first term. A sub 2 is the second term. A sub 3 is the third term. And we're finding the first 4 terms, so I need an A sub 4. And these little subscripts just go in for the letter N. And you just do your order of operations. That's all that is. So this is going to be 3 times 1 minus 2. This is going to be 3 times 2 minus 2. 3 times 3 minus 2. And 3 times 4 minus 2. So the first 4 terms in the sequence are 1, 6 minus 2, 4, 3 minus 2, 7, and 10. So that's it, guys. There's the first 4 terms on that. Oh, I actually wrote a minus. Oh, so I just wanted to make sure y'all remembered it was a positive. I wrote the wrong thing at first. But it's just a regular plain 4. All right, y'all. Let's see what's next. So for problem number 2, it got cut off, but we have the letter N right here. So again, our subscripts are just going to be our substitutions. So A to the first, A to the second, A of the third, and the 4th number. All right, so we're going to have 3 plus a negative 1 to the first power. 3 plus a negative 1 being squared, 3 plus a negative 1 being cubed, and then a 3 plus a negative 1 raised to the 4th power. Now, remember guys, these right here, they're going to have the same answer because negative 1's raised to an odd power. The other 2 are going to have the same answer because any negative 1 raised to an even power is still going to be the same exact thing. So, our first term is going to be 3 plus a negative 1, so this is just a 2. But over here, remember negative 1 squared is a positive 1, so 3 plus 1 is going to be a 4. And then again, a negative 1 raised to an odd power is going to stay a negative 1, so 3 plus a negative 1 is a 2. And then a negative 1 to an even power is going to end up being positive, so this turns into a 4. So that's going to be the answer for problem 2. Those are the first 4 terms. Now let's take a look at the third problem. So for the third problem, oh, my copies got cut off again. We're still having a negative 1 to the nth power, but it is on top of the fraction bar. Work on our order of operations. This is going to turn into a negative 1 on top. Underneath is going to be just a plain 1. And guys, don't forget we need to simplify our fractions. So A sub 1 is just a negative 1. A sub 2 is going to be a positive 1 on top. And then this is a 4 minus 1. 4 minus 1, of course, is a 3. So here's our second term. Our fourth term is going to have a negative 1 on top. And then our bottom term is going to be 6 minus 1. So a negative 1 on top is going to make the whole fraction negative, guys. So just scoot that negative symbol out to the front of the fraction. This last one's going to be a positive, though, because a negative 1 to a positive or to an even exponent is going to be positive. So this is just 1 over 7. All right, guys, that's how you find the terms. Pretty straightforward. Wherever the letter N is, you just drop which number you're working on. The first, the second, the third, the fourth, whatever. All right, let's shift gears. And now let's have the things given to us, and we have to write the rule. So the rule comes from how the terms are increasing or decreasing. For example, let's look at this. How does a 1 get to be a 3? Plus 2. How does a 3 get to be a 5? Plus 2. How does a 5 get to be a 7? Plus 2. When you have these first level consistencies, and I will show you what I mean. These are first level consistencies. That means you have a 2 in front of the letter N. So this becomes 2 times N. That is part of our rule, but it's not the rule, guys. We have to make some adjustments. Let's take a look at this value right here. That is a value of 5. And it is also 1, 2, 3. A sub 3. So here's what we know. We know A sub 3 equals 5. I'm going to use this information and plug it into this rule. So it is going to be 2 times 3. And then you always need to adjust something to make this a true number sentence. Y'all, 2 times 3 is 6. So what am I going to do to turn it into a 5? Subtract 1 is correct. So according to my rule, y'all, I should be able to do 2 times n minus 1 and get all these numbers. Let's spot check it. Remember, this is A sub 4. So if I do 2 times 4, because 7 is the fourth one, 2 times 4 is 8. 8 minus 1 gives me this output right here. So, pretty confident, absolutely, that's the rule. I'm going to box this in. All right, so remember, the rule comes from how the terms are increasing. And then, always either add or subtract to get the exact value. And it'll work for all of the terms in the sequence. Let's practice this again, y'all. Let's look at problem 5. So for problem 5, we have these numbers right here. Let's take a look at how they're increasing. So a negative 2 to a 1, that's plus 3. But guys, from 1 to 6 is not plus 3. What is it? Yeah, so look. And then, that's not even plus 5. What's this one? Yeah. All right, so over here previously, we had the same answer. This was a level 1 consistency. This isn't consistent. Let's see what happens between these numbers and see if they increase by a consistent amount. A 3 to a 5 is plus 2. And then what about a 5 to a 7? Plus 2. So what we have here is a level 2 consistency. when you have a level 2 consistency, it's an exponent. So here, n is going to have an exponent of 2. And then the process is the same. Let's go ahead and plug in a value and adjust our rule. I am going to plug in this value right here. I'm going to use 13. 13 is the 4th term. So I know my n is going to equal 4. Here we go. So I am going to use a sub 4. That's going to be 4 squared. And what needs to be adjusted to make this a true number sentence? What goes here? Minus 3. That's it. 4 squared 16, but we need it to be 13, so minus 3. So let's put a minus 3 on our rule, and guys, just double check it. Let's do the first term. Y'all, the first term should give us a negative 2. So if I plug in a 1 right here, it'd be 1 minus 3, which is totally negative 2. So this is the correct rule. That's it.
Can you pick any of the numbers to use?
Yes, any of the numbers you want. That's right. But no matter what, we should absolutely get the exact term, no matter what position we're in. Okay, guys, listen. For number 6, you definitely need to write this down. It's nowhere in your packet. It should be in your packet, but it's not. All right, so here's the deal. If you notice, these signs are changing. It's flipping back and forth. Starts out positive, flips to negative, flips to positive, flips back to negative. When this happens, you have to add an extra piece. And we're going to call this extra piece a sign switcher. And here's how this works. When they alternate signs, if the first term is negative, then we're going to put a negative 1 raised to the n power right before our rule. But that's not what this is. The second number is negative. If the second number is negative, we're going to do negative 1 raised to the n plus 1. And guys, let's just make sure we're good on like this whole n business. A sub n, that stands for what I'm looking at right now. And then a to the n plus 1, y'all, that's what I'm looking at next. So just be, let's just be clear on what those n's stand for. All right. So we're going to use this second one right here. So I know what to do to take care of these negatives. I'm going to put this in front of it. Since I know what to do to take care of those negatives, I don't even care about the negative signs anymore, guys. Let's just analyze absolute value. A 2 to a 5 to a 10 to a 17. Let's find the common difference. So right now, 2 to 5 is plus 3. 5 to 10 is plus 5, and then 10 to 17 is plus 7. Again, we don't care about the negatives. This is going to take care of the negatives for us. These are not consistent, so let's keep going. 3 to 5 plus 2, 5 to 7 plus 2. That means we have ourselves an exponent. So with that exponent, we know it's going to be an exponent of 2. N is going to be the number in front, but don't forget, we're going to have to adjust by either adding or subtracting some value. And guys, we're using this right here. Now remember, this is first, second, third, and fourth. I'm going to plug in this second value right here and figure out how to get it to be 5. So this is the second number, so n is 2. This is 2 squared. What would I add to that to make it a 5? Yeah. Cool. So I know I need to add a +1 here. Let me just double check it just in my head. Here's the third term. If this was 3 squared plus 1, I would certainly get a 10. And that I am very confident about being the answer. But we got to put this in front because the signs alternate. Here's how this is going to look, guys. Here's the rule. It is going to be -1 raised to the n plus 1 times this right here. N squared plus 1. That rule matches this pattern exactly. So that's the answer.